Thanks for the opportunity of coming today and talking about the Hypertraxs GR8. Right, okay. My name's Steve Nicklen. I used to work for Network Rail for 10 years. I've been in the S&C industry for 30 years now. Worked for various other manufacturers. And since 2015, I've been a rail consultant and working closely with Hypertraxs on the coating. So what today is about for me is to actually just take you through the story, in effect, of how we started when approached by Network Rail, by Neil, in fact, when Neil was with Network Rail, and just bring you up to speed with exactly where we are with the coating. I'd just like to say that originally we had planned to bring Andy Clark, who's the technical manager for Hypertraxs. He's unfortunately not been able to make it. Neil's quite kindly stepped in, but the presentation in parts is quite a lot of technical detail, and I'm not going to be dragged into the minutiae of that, but it's the story really, which is the important thing, and the benefits that I want to talk about. Have you got anything to say, Neil, before we start?
No, I can just introduce myself, I suppose, so people understand what I give. My name's Neil Denton. I started in the rail industry in manufacturing in 1974 at a company called Taylor Brothers at San Diego. Went on to be Thomas W. Ward's, Rio Tinto, Henry Boot, Alpha Beta, it's now called Progress Rail. I was there for 27 years, and then I came across to maintenance in 2000, which I worked for Network Rail, worked my way through to Network Rail. I was my title within the business in 2009 was National Senior Reliability Improvement Specialist for S&C. So I dealt with all the S&C failures, because basically S&C is the only thing I know. Worked for Network Rail for 17 years, and then went to two other companies, and now, at this moment in time, I've just started my own business at 67, when I'm sort of like subcontracting myself out to a company called Intel Rail at the moment. And that's me, basically.
Okay, so I'll move to the first slide. So this is an executive summary, just to kind of give you an overview of what Hypertraxs GR8 is all about. It was developed to provide the kind of wear prevention on switches, especially trailing switches, or indeed any switches which suffer from high wear problems and all of the issues that come with high wear. In 2015, when we were approached by Neil to say, have you got a solution to this switch problems, it was decided that trailing switches was probably a good starting point because of the excessive wear. So that was the kind of the basis of the trials we started doing. The trials, of which there were 7 trials over multi-years, did kind of start to show that the coating was having the desired effect, and that it was making the switches last longer. The benefits of that obviously is reduction in maintenance, which was the business case in the start. Whole life costs, which is really important, or should be really important. And latterly, throughout although it didn't start that way, throughout the journey, the boots off ballast message started to come, because people started to look at the correlation between if you're having reduced maintenance and if we're not having to do as many interventions, actually you're keeping people off the track. So that kind of grew in importance. And it also started with Neil, but it started with the Network Rail challenge statements, because Network Rail published some statements saying what they wanted solutions for. And this fitted really neatly into, in a nutshell, can we make S&C last longer? Because every time we've got to go and maintain it or replace it, it causes all the issues that we all know about. What we've been asked throughout the trials, unsurprisingly, is can this wear resistance coating help in with other assets? And indeed, it moved on to stock rails during the trial. One of the trials says, well, we've got a problem with the switch wear in this particular area, but we've also got similar problems with stock rails. So they expanded the remit of the trials to include coating of stock rails, especially the last one was the Nottingham trial. And very recently, well, probably 10 months ago, we were advised that to get things keeping moving and get the approvals that we needed to do the design for reliability path. So we've done that. So that's the kind of a very kind of general overview of where we are. The graph on the right is just a graphic to show that the coating is actually making the components last longer, which of course is the whole point of applying it. So S&C switchblades. I mean, Neil probably lives and eats and breathes these kind of problems more than I do, but that's just a summary of all of the kind of issues that we'll get with specifically with switchblades.
It all started in about 2002, 2003, with the introduction of RT60 design rail. The only full 1 in 20 design that we've ever had is bullet, because the start rail on the switch sits at 1 in 20 because it sits in chairs. When we went to vertical, we started to put it into plates, which set it vertical. So when we was looking at incline switches, you've got an incline switch which sits in a 1 in 20 slide plate, but the switch blades are vertical. So basically what Network Rail wanted to do is they wanted to make a 1 in 20 version of RT60. So because they couldn't get the cant on it to give it the 1 in 20, what they did is they machined the head and put a 1 in 20 into it. But the problem of it was, on a trailing wear, you got an intersection point where that machining stopped because the topping heights had been dropped because it was designed for facing moves. It was the trailing moves that was doing the damage. So this is where we started to look at accelerated wear. In some areas, especially on short switches, it was happening a lot on C's and D's. And basically, we put in switches in, and within 20 weeks was weld repairing them. So this was the RT60 design, exactly. So then, head office looked at it, and then they went on to the NR60 design, which they've still got now. Still had its issues, still has its issues. But I think the trailing wear in shallow depth was way before RT60 was introduced, when we was looking at full depth, 113 pound UIC 54. And there were signs of it there. So it has been around for quite a while.
Okay, so clearly the risks are pretty obvious. Once a switch is failing or needs replacing, all of these risks, trail derailment, more people on track, switch, they all have a monetary cost, and quite a significant monetary cost. So as was set out at the beginning, and it was a very, very simple message at the beginning, it's tending to kind of got into a lot more detail, but it was really basically only you've got a coating which is a technology transfer from other industries, because you use it in nuclear, oil and gas, and it gets applied to different components to make those components last longer. You do it for track, and that's really as simple as it got, and the answer was yes, because we developed this quite a long time ago, actually, for the railways back towards 2002. So that's how the journey started.
In some areas, what they was doing is they had to add a regular booking of welders to come in every 2 months, and because they were failing SO53, so they had to come in and weld repair them, not so banter-facing moves. So the team was booked on a regular basis. There was areas around Derby where I was working at that particular time that had got regular possessions for welders to go in to weld repair.
Yeah.
I think this is when I spoke to, when we went to the meeting, and this is when I spoke to Steve. And this was a few years, many years after. I think it was about 2015.
Yeah.
2015. And we was looking at the corrosion that Hypertraxs had introduced, like down in Dawlish, where they've got that corrosion protection for tunnels, and around the Dawlish area where you'd got the salts. And then it mentioned about, so it's just a shame that you can't give us a coating that's going to stop the friction. I think as we can, and that's where it all started from there.
Yeah, Brian Whitney was actually at that first meeting.
Yeah, it was.
So yeah, so that was our challenge really there, and you know the points was everything that we've just really said, to just make the components last longer. We proposed Hypertraxs GR8. It was an existing developed process that we use in other industries, although it's not exactly the same. It's a high carbon based coating. We've done the smart feasibility study back in towards the beginning of the 2000s. Wear resistant coating. The pattern, as you see on the picture there, was the original trial at Stafford, which was the very first one, Doxy Road. We tried to anticipate what the pattern of the coating should look like, and we actually put it as round shapes. And after about a year, we went back to Stafford, and when we kind of had a look and inspected it, and we discovered that we didn't probably have enough coating on there, that the rounds didn't actually key as well as they should do. So on the second trial we did, because this is the way it's been working, you kind of learn from what you do, and that's what it's all about, and that's how you develop other coatings or enhance the offering by working very closely. We decided that the honeycomb pattern, which has been around a long time, that was a much better solution. It still gave you the troughs all the way around, but actually it provided 80% coverage where the rounds were only provided about 45% coverage. So that was the second honeycomb pattern that's been in all of the trials since the first one at Stafford. One of the beauties that we discovered, and we didn't actually hand on heart, we didn't plan it, but because the lubrication and the interflon that we were told by Network Rail was being applied to the switch blade, because you can see the troughing around because these honeycombs are slightly raised, they're not very thick, but 200 microns, but the lubrication was actually sitting in the wells. And so the engineers that we were dealing with at each of the sites were telling us that lubrication was staying in place a lot longer, so it almost became like a friction modifier. So again, another advantage of it. And on the last three trials, we were told that we needed to apply the lubrication before we sent the switches to site.
I think what it was with the lubrication is that the OG grease had been introduced as the preferred product to use for SO53 for lubrication. We didn't know whether or not that might cross paths with what Steve's business was trying to do, but basically we got no choice because the OG was going on anyway, and like Steve says, it's pockets and it holds it and just releases it, and it just extends the life.
Yeah, it enhanced what we were trying to do with the wear resistance. It just added to the benefits of that. So, as I mentioned, we were given various trial locations by Network Rail. We wanted to work closely with Network Rail, so we went out and carried inspections. We gathered the data. We supplied Network Rail with the data and how they were performing in track and how we were learning. Network Rail provided us with a lot of their data from previous uncoated switches, so we could start to do comparisons. We inspected all the sites where we could. Some sites were, I think Eastleigh was electrified, so we weren't able to get on track, but we did it by proxy really and got the engineers to look at things that we wanted to look at. So we've worked hand in glove with Network Rail all the way through the various trials. This is kind of probably a little bit old now, but that's the kind of trial sites. We reported everything that we found. And we were always accompanied by Network Rail, so we were always accompanied by the engineers who could ask questions and they could give their opinions, and which were generally all very favourable. And the example we're going to use is one of the last trials we did, which was at Nottingham Station.
I think what people lost the vision of is that because we'd got issues where after 20 weeks we was weld repairing switches, that people were saying, yeah, but we've been down to site and the coating's gone. But that's when you look at the value of how long it took to take the coating off to when it starts wearing from where you start if you put new switches in. So we know it's about extending the life of it. That's what it's all about. So yeah, the coating will not be there forever, but that's when you start to count down on the life of the switch without the coating.
Yeah, it's by how much has it extended the life before first maintenance, really.
And the coating's gone. Do you reapply it, or is it just a one hit?
That was asked a number of times.
Yeah, that's always asked. But yeah, the answer to that is we can. But bear in mind, this process has been about proving to Network Rail that this innovation actually works, and this is why we've had very long-term trials. To actually put something in, and it'd be by way of a maintenance train that you would have to hold, put over the switches and reapply, that would be a cost. And if we're providing to Network Rail and it's a fully approved product, obviously we would be happy to start looking at that as the next stage. Just very difficult to move on to the next stage before you actually get up and running. So it's a chicken and egg really. But yeah, to answer the question, technically it can be done. As we stand at the moment, it's just for new switches and crossings. And other components, we're actually doing other work now off the back of what we've done with Network Rail for non-Network Rail switches and crossings, and British ports have approached us, tramways. So there's quite a few other companies that will start to say, they're seeing it in a very simplistic way, saying, if you can make things last longer for us, this is great. And as Neil's quite rightly said, it's not Holy Grail. Somebody actually said to me once, you say, well, so this is it then, you don't have to kind of replace your switches anymore. Well, no, it kind of will wear, but it's just bought you more time and prevented expensive interventions. So that's the key.
The main factor of it is that it's a trailing wear issue. So it's only in reverse. It's when trains are coming through on a reverse move. So it's the reverse switch that gets the most wear.
And just to finish on that one, the other non-Network Rail interest that we have in, as Network Rail have done really throughout the journey, they've now coming up with other components, because it's basically anything that wears and causes them an issue. So they're talking about, can you do it for check rails? Could you do it for wing rails? What about expansion switches? So people start to look at it as a solution, say, just apply this. With Network Rail, and both Lee and Neil coming from Network Rail, we knew that we had to try and keep it focused and not do a scattergun approach, because that wouldn't have been helpful. So although people, and we talked to signalling people, and they said, we've got some wear issues, you need to come and talk to us. So we said, but actually we've just got to kind of concentrate. And then once we can get through as it is a switch or a stock coating, then it's easier to expand that to other componentry.
I think that when Steve mentioned regarding the coating and the pattern, it was the circles, then it was the honeycomb. Well, in theory, they're just two. So it's about future development, because I'm sure we can squeeze more life out on it if we look at the pattern in the future. So it's working with Network Rail and trying to develop a different pattern that's going to give them a longer service life until it wears down to the rail.
Okay. So this is the bit I mentioned at the beginning, where we actually, as part of the trials, and we had to present a Network Rail, we employed a independent statistical data analysis engineer, and he was like, his head was about that big. He got into the minutiae of all of the data that we got back, all Network Rail data. So none of this was we only kind of used what we got back up from the trials and Network Rail. And he cleaned up the RDMS data from Network Rail, because the databases are massive and there were some anomalies which he kind of made sure was a good platform to work from. It was basically, he wanted to prove what we've already spoken about, is days between interventions, or extending the life between interventions. And then he discovered what is the most suitable metrics for actually coming out with the analysis. And we ultimately presented this to Network Rail, the findings, about 18 months ago now. So there are some really complex things coming up, which if Andy was here, he would have handled. But I'm not going to kind of get drawn into trying to pretend I can explain them to you. But I think the general story is to show how much detail and cost that we went into to make sure that the data we provided back was accurate. So as we said, the Nottingham trial site was the one we selected for the presentation. The track engineer was a guy called Pete Green. I think he's since moved on. He's maybe into the safety area now. But Pete was really helpful, very enthusiastic, very keen. He, as with everybody we spoke to, he wanted to tell us about all their problems and how these switches are a nightmare and all the knock-on effects. So Pete was really helpful with us. Again, as with all of the trial sites, Network Rail decided. We didn't decide. They said this is a problem area. Trial here. I'm sure you know this. You'll probably recognise the photo, Neil. But it was a very difficult half set of switches, which was coming out of Nottingham Station into the depot, and it was getting hammered. And we also confirmed during the trial, because obviously COVID happened, that the annual tonnage didn't drop significantly, if not at all. So they couldn't say, oh, it's been less trains running over. So because that would have maybe diluted the trials. So this was the first one that, might be in Glasgow, but this is one where they wanted the stock rails and the switch blades coating, and they wanted it an extended length because we were coating at 2.9 metres. But they decided, because of their particular problem, and this is very prescriptive about what problem each guy and what set of switches has. So that, as Neil said, we can design that going forward. We can actually tailor the solution more. So they wanted an extended area, and as we mentioned earlier, it's 200 microns, about 0.08 of an inch. So that didn't cause any issues with anything. We've established that throughout the trial. So that was installed December 2019. We've been back to track several times and inspected it, and it was all very, very positive. And Pete himself was a big advocate and said he's definitely impressed by what he saw.
Well, that was an unbeknown benefit, really. It's because when we was doing the SO50 to the rewrite, there was only looking at the first metre within a switchblade. But now the SO53 goes the whole length of the machine blade. So in theory, what you're doing is, because you're doing your 53s, it's protecting it further back, which didn't come into the equation on the original standard.
It's interesting. Again, something that we could claim to design, but we didn't. But Brian Whitney has been involved in this, and obviously an interested party. And when we're deciding how much a coated length needed to be on a particular switch, and where should it start and where should it end, then that's based on the problems. Brian was an advocate of actually extending that coating area a little bit, because he said, you might put the coating on, and your problem area in the first 12 to 18 weeks is at that point, but actually that problem could migrate over time, over the life of the switch, and it might be that in 40 weeks, your area that you're trying to protect is a little bit further down the switch. So great advice, and we were guided by the likes of Brian, obviously. So that's the Nottingham trial. I think we're probably going to go into some intense data now. So
I suppose if you look at it from the basic engineering, we always normally say that if you've got a machine part, you lubricate it, don't you? You grease it to protect it. So if you've got a lubricate, if you've got a machine face, if you coated it in the coating, basically it's going to protect that face.
It is a technology transfer, and many people quite rightly say, yeah, but this is a rail industry. Rail industry is quite different. But really, it's metal against metal wearing, and that's what this has been designed to do. And so there's no real reason why, although you've probably got to design it to the nuances of the railways to a degree, no real reason why it shouldn't work on a railway, because all you're trying to do is add a coating to prevent wear.
It's reducing friction.
And reducing friction. So this is the data. There's a mass of data, but I think you'll see that basically the coated switches versus, and we were given this information from Network Rail about the previous 3 uncoated switches, and basically it's a good news story, because where the coated one is, how the coated one is performance significantly in nearly every case is doing a lot better than the previous 3 switches. And that's all it was about, really. That's although Tim's getting into a lot of detail, the analysis that he did based on their data is that the coating is having a significant positive effect.
You've got rail life down there on the bottom right. I take it that's days.
Yes.
What's going on there? Because the 638 days Hypertraxs is less than the previous coated. Is that an anomaly?
This is still, I think this is a year, this has gone a year on, and that is still in. So
Okay.
you would add 300, I apologise that, but we've not had a chance to, because
Oh, right, so that's
we
when it
did the
was cut
data
off,
when
and it
we
was
presented
its
to
time
Network
state.
Rail,
Okay.
yeah.
Uh-huh.
So there have been some anomalies, but then they've said, oh, we think this is for a different reason, and it's a different, you know, a reason where the coating probably wasn't the solution to help. But generally, the vast majority, and as I say, Pete Green was very happy with what he was seeing. And he actually said that my next coat switches are going to be coated, and I kind of said they're not, because we're still trying to work through the approval process. But
Product approvals, we all know that. Yeah.
and we had some great news on Friday actually, because I don't know if you know James Dean, he's Route Director for LNW. James has been our sponsor throughout the journey. I think one of the problems is we've product approval is quite time consuming, but I think what hasn't helped, and through nobody's fault, we started with Neil. It was great, we were trucking. Neil moved on. We inherited somebody else who didn't really know much about it, but they took it on. They moved on. So it kind of stops the process really working. Then, to be fair, somebody gets in, given it and think, well, what's all this about then? And to a degree, we've got to then start again trying to go through the hoops. But it is what it is. It is what it is. But yeah, that's the Nottingham trial has been a very, very positive trial. And we're just trying to gain some benefit. Again, we go back to what I said 10 minutes ago. It's not a holy grail. And you can't just look for solutions that gives you the absolute brilliant, that's it, everything's going to be rosy forever. But Network Rail's challenge statement said, and Network Rail have told us, anything you can do to give us advantages with the range of issues we've got, especially with switches, but with other things, we'll take it, because we're looking for anything that's going to kind of help.
But what you've got to remember is, with my involvement of S&C for the last 49 years, right, is that if you're going to set a trial up, that you need to go back to basics. If you take it from a simple point of view, is that if your tyres are tracking and you go in and you have a new set of tyres down at the tyre place, then you ask them how much it's going to be to track it, and they'll say £35. I'm not paying that, because they look great today. But in 3 months' time, it's going back in for a new set of tyres. So when you're doing a trial, what you have to do is you have to do a survey of the switches first, because any issues with installation and the way that they're operating will affect the way that wheel interfaces with the running rail. So, if you're going to look at a product, the product can assist you and extend life, but it's dependent on the way it's installed and maintained. So, that people don't take that into factor, because they'll put it on poor performing points. Oh, we'll put a new offset in there. Yeah, but you're out of square, you've got issues with gauge, it's going to happen again. You say, well, it hasn't been on long. No, because it's accelerated wear again. So you have to take all these factors into play. Well, I do, because that's my business.
Again, the graphic probably tells you everything you need to know, and this is all of the data that Tim's company pulled together for us. So basically, you can see the bullet points there. But the blue are the uncoated switches, and the orange colour are the coated switches. So across the board, although there were some higher and some lower, we were estimating that by putting this version, and Neil's point's a good point, because we've got some ideas about how we can make it better still, but we're not actually developing that for obvious reasons yet. But we're thinking about 40% betterment of life of the difficult switch blades and the stock rails. So far, the analysis tells us that. Wow. Right. Neil's going to explain what that means. Again, this is really just mind blowing, really. But this is what we presented to Network Rail, and this is really to kind of show the lengths we went to, because it was all Network Rail data to extrapolate the data and to present the data. And the people we presented it to were the technical engineering team. So Tim was with us, and he was on hand to actually explain what was happening here. From my point of view, it just shows the the length, and it was a 6-month project for Tim to bring all this information together, the lengths we went to. So I really don't want to get dragged into any formulas, if you don't mind.
And from my point of view, it's a right-hand switchblade.
Oh, got some more.
Yes, so we're on the same slide, aren't we? So yeah, so it was the 95% confidence level was a very high, I'm told, parameter about how the data is very reliable. And in the red, it's the red bits that I coloured in last night. That's the really key points from this data that was carried out, that the statistically significant and a high degree of confidence that the coating is doing what it's meant to do and actually extending life. And very similar. So yeah, it was a very successful trial, the Nottingham trial. Some trials we did, maybe Chinley, we discovered that maybe the coating wasn't the right solution because there's such high freight traffic that it was causing different issues, which with hindsight you think, well, maybe a coating's not gonna help with that. It's not a wear issue. It's a kind of a crushing issue. So it is important where we ever put this in the future, that it goes in the place that actually is going to benefit. It's like a lot of things, you know, and if it doesn't benefit, then it shouldn't go in that places. But as we've learned, there's an awful lot of high wear issues in the railways.
I think what we was trying to do is we was trying to look at a solution to stop wheel wear. It's just dawned on me when we've just spoken about this, is that, you know, what's to stop them coating the wheels? Because we know the wheels play a big factor in the wear on the RS&C when you're running freight across passenger lines. So why don't we coat the wheels?
I can think of one reason. Is this coating electrically conductive?
No.
Then there's your reason.
Yeah,
no. Are you talking about, does it affect it?
No.
No.
It is electric, yeah.
It is
Yeah.
conductive. Oh, okay.
Yeah.
Right.
Because one of the things that Brian wanted to do too is that what he said was when we first started this, way back, Brian says that we need to be careful because if it does wear, then we need to weld repair it. So what we have to do is we have to prove that the weld repair doesn't affect with the coating on it. And I went down to Walsall, went down to the training school, coated some rail, welded it, not a problem.
Yeah, and it can be removed. So under normal, you need a diamond braid, but that's Network Rail standard kit. One thing when we set off on this, and I think working for Network Rail helped me, is that we knew that whatever we did and whatever we proposed for the future, and when we're going to introduce this, it had to be straightforward. And I said to the guys, if you make something that's going to be, well, you just need to go hire this special bit of kit, and it's not going to happen. So everything that we've done fits in with Network Rail's natural, normal maintenance methodology.
But I suppose if it was going to stop electrical current, we wouldn't put it on the switchblades, would we?
I was thinking about track circuits and detecting trains. Obviously, that's done between the wheel and the rail.
Yeah. I mean, axle counters.
No, track circuits.
Oh, track circuits.
Yeah, there's no effect on that.
No.
It's,
Right, okay.
as you can imagine, it's been such a long journey. We've managed to go through lots of hoops, and you know, and as always, people say, "What about this? What about removing it? Well, can you do it in situ?" Which has never failed to come up, and which you ask. So yeah, and you know, does it cause wheel climb? Is there any kind of is there any problem with the fitting of the switch? To do with tolerances and tolerance building up, and again, Brian's been very vocal on this, and each one has kind of said no, there's no kind of impact whatsoever. So, right, okay, yeah, and it's the same again, really. So this is the chart again. It's like the similar one where it says not happen. The switches are still in track. This is about a year old, so you can add 350 days onto the figures. And generally, again, it's just painting a very positive picture of you've applied the coating and you're getting a benefit. If anybody wants access to, you know, if somebody really wants to dig more into that, we can make this presentation available. I can give you a link to how you can access it. So anyway, just thought I'd offer that. Again, we're still on Nottingham. Again, it's just painted a positive picture. Meantime, between inspections, and again, the orange bars are the coated blades, and the blue are the non-coated information that we got. So, yeah, again, it's a very similar slide, I think, because we're back to the 40%. Yeah, so again, this is basically saying that you're doing more maintenance on uncoated switches, but the important thing about this slide shows, and again, it was a question asked, is it more problematic to install? Is there a different methodology when you've got a coated, you have to treat it differently? And what came out of this is there's no difference whatsoever. So the Network Rail's normal practices, what they do normally with a standard switchblade, just because it's got a coating on, doesn't make any difference, and it doesn't add any more time to it. So, the Nottingham trial, coated half set outperformed the previous. That was stated. The coated bedded in. We knew this happened. So as the coating starts to kind of be removed over time, it actually starts kind of entering the the surface of the rail. So although you can still see the pattern of the coating, but it's not as pronounced, it's actually bedding itself in, so it's still actually doing its job. The third point is, and again, Pete Green on a site visit said, this is really interesting because where we've put the coating on the stock rail, we don't seem to be getting anywhere near as much RCF. And I'd like to...
You might want to explain what RCF is, because there's people who aren't tracking.
Sorry, yeah. Well, I mean, if you go back to, I lived and breathed 20 years ago when RCF first hit or was identified, also known as GCC, gauge corner cracking, and it was like a tearing of the surface, and and it was all over the place. And the more they looked for it, the more they found it. And I think my understanding is we're kind of living with it now. But when that point was made about it seems to be preventing or slowing down RCF, we couldn't, hand on heart, say, yes, this is designed to do that. If it helps, then great, but it wasn't, this isn't what we were trying to achieve.
I think what's interesting for me, because I didn't get involved with the Nottingham, because I think I'd left Network Rail at that particular point.
Yeah.
I've just noticed that this is on full depth switches at Nottingham Station.
Yeah.
So are these on the curve?
Yes. Yeah.
That's, you know, the more curve we put into something, the bigger impact it's going to have on wear. And I can see here, look, 56E1, it's got a bolt in it, so that's full depth. So I always thought it was the shallow depth switches that was the trailing wear.
Well, it's interesting because, as I said earlier, we were trying to keep it focused because of what the journey we were trying to,
It was RT, it was looking at one.
Yeah, but it was the engineering, because we did quite a lot of seminars as this journey was going on. We were asked to go and talk to the engineers, and it was the engineers on the routes that generally expanded it. Said, look, I know you're trailing switches, but I've got a problem on this switch, and everybody had different problems. So that's when it started to kind of expand it, and it became clear that it wasn't, although that's a big problem, trailing switches and C's and D's, it wasn't the only problem. So that's when we started to expand the type of switches that the coating was applied to. We know at Nottingham, because Pete told me, this is probably going back 7 or 8 months now, but they'd extended their inspection. They'd reduced, they'd missed 3 interventions, and he said, by now we would have been in 3 times. We haven't touched it yet, which has a monetary value as well as a safety value. But he said the degree of confidence has gone up, so that they expanded it from 4-week to 8-week inspections, which again is keeping people away. And so it was a very positive trial for us, the Nottingham one.
I think one of the biggest issues that we got was when it was mostly within stations, where you got tight curves coming into stations. And the problem of it was, if it had an SO53 failure, it would be banter-facing moves, so it closes that platform down. So the impact it has on the business is massive.
So what we've done as Alphatech, who don't have a contract with Network Rail, and we don't really want a contract with Network Rail because that would mean a tendering process and all the business, is we realised that to be successful, and if we got into production, we got product acceptance, we would need a route to market, and a route to market needed to be a tier 1 S&C supplier who have an existing long-term contracts with Network Rail, who we could work with. We would be the coating entity of them. They would be the switch providers or the stock providers, or indeed would deal with any of the other companies, because we can't restrict Network Rail to whose switches get coated. It's got to be Network Rail will decide, and if it's a Progress Rail switch, then make that happen, and if it's a Boslow switch, we'll make that happen. And that's the way we geared up through the trials. So we've got to deal with Trackwork UK. We're currently just setting out how logistically it would work, how people would, because basically the guys in the track, they just want to put an order in, and 6 weeks later or 8 weeks later, they just want a set of coated S&C. They don't want to kind of get bothered how this is going to happen. So we're talking to Network Rail procurement, and we're just coming up with a methodology of how it can be simply applied, so people can, on their ordering, on the Enroll ordering form, whether just tick the coated switchblade option. They don't have to do it anymore. They don't have to say, and I want it this long and I want it this pattern. That's all a given. So we're working closely with Trackwork. Obviously, we mentioned Interflon earlier on, and we're still applying Interflon. And we're collaborators, really. We've tried to collaborate with Network Rail. I mentioned, and I think I kind of didn't finish it off, but James Dean has been our sponsor from LNW. And James Dean has now suggested to us that he wants to act as the route facilitator. So LNW, which is a big patch, to start using being able to order the switch and stock blades, put it into areas where they say that it's needed, where they've identified a problem, and then roll it out, because that's probably more sensible to kind of appraise it as people are using it, and it's not a trial, because we're not doing any more trials. We did 7 years worth of trials, so but he said it's not a trial, it's just, and there's going to be no special monitoring. It's just going to be normal 053 inspections as standard as Network Rail monitor everything that they've got in the track. So we got that kind of news last week, which we're very enthused about and very keen to, work closely with Network Rail to get this moving.
I suppose it's a little bit like EDH on cast manganese crossings.
Yeah.
Explosive depth hardened. Everybody's going for explosive depth hardened. The cost is there, but the implication is that you get a longer life in your crossing. So it's just an introduction, basically. So that means that virtually every EDH, every crossing, cast manganese crossing going now is EDH. So hopefully in the future, all the manufacturers will manufacture, send them to Trackwork, get them coated, and everything will be coated.
Yeah. I mean, this would enable us to make a significant investment, which we've got in the pipeline with Trackwork to set up the facility up there. They've got a huge building where they're actually going to put strategic stock for Network Rail. They're going to hold large quantities of over-length blank switchblade stock blades, so they can be on call 48 hours. And the plan is that we're going to put a factory in that coating facility, which is ideal next to, and we're going to do batch coating, so that it's going to reduce the lead times.
Who actually does the coating? Is it your people, or are you training?
No, it's Alphatech. It's Alphatech, and Alphatech would be based over at Doncaster at Trackwork. They would kind of run it. Obviously,
right, okay.
Their process. They want to do it.
Yeah.
But this would move it onto a hugely different level where. And Network Rail's desire, actually, which suits us down to the ground, is they said we actually don't want to, although there will be some, they don't want to say, I've got one set of switch that I need to move to be coated. They want to use the strategic stocking, so they'll hold 40 half sets of Bs, 40 half sets of Ds. And other manufacturers are doing the same.
But they could do that for each manufacturer, couldn't they?
They
could have a stockpile for Progress Rail.
Yeah. So
Boslow.
We've not been able to apply that kind of investment whilst we've not been in full production or through the approval route. But we're very hopeful now that once we're kind of allowed to start producing and delivering these, that will allow for us to, and it's our investment, it's not Network Rail investment. We've committed that we would put that investment in place and set up a facility. So this is just where we started, really, the challenge statement from Network Rail: reduce reliance on maintenance. We've tried to do that. Prolong the life of S&C assets. Whole life cost is a tricky one, hand on heart, because although the people and dozens and dozens and dozens of people we talk to about whole life cost benefits, and everybody accepts it, that's what you should be doing. You pay £50, but you save £500. It's a difficult one to get through that, because a lot of people's casks and rolls are unit costs, and it's very difficult to start to say somebody that's driven by, that's 20p and that's 25p, I'll get the 20p one. It's very difficult to get into a conversation saying, yeah, but look at the whole life cost benefit from the track because it's not within their remit. And as frustrating as it sounds, you kind of got to think, well, yeah, I know what your remit is, and it's not helping what we're trying to do based on what Network Rail put out as this is what we're looking to get help with, really. So we keep kind of trying, but
I think for me what it is engineering. When you're developing a new product or a new design, it's all theoretical. It's all theory. The problem is, it's great if the theory works, but the problem is if the theory is set out that it will work, that means you've got no frequencies in place to deal with it when it doesn't. And that's one of the big issues that we've got, because you have to look at it as a whole setup. If it works, it's great, and we'll go that path. But if it fails, you need plan B. And a lot of the time, just keep looking at plan A. There is no plan B. So this is when maintenance have to try and push their resources into re-welding. And it's all at cost to the DUs.
Well, James is said before he's very keen to start using it on Euston Throat and you ran Euston Station, those areas, and he did tell me the cost of a platform going down because of a set of switches failing at Euston Station, and the numbers are staggering. So this isn't going to solve everything, but he's happy to try and get any benefits he can, and if he can extend life.
They've lost 2 platforms to the high speed 2 as well, so they're now running on.
Yeah, indeed.
There's no wriggle room.
Yeah. It's that knock-on effect, isn't it? It's that not looking at that kind. It's like what happens if the platform goes down in Euston Station, and they say I was staggered when he said the kind of money he was talking. But anyway, so I think we've covered all that anyway. But I'll just go to the bottom. But the only impact that we've discovered through the trials and through all of the data analysis we've done is a positive impact, and we're really keen to try and provide that benefit to Network Rail and work closer with Network Rail, and as we said earlier on, develop the coatings and develop the products that could benefit from the coatings. So this is the end. I think it's just a summary. What does it do? Provides enhanced wear protection, prolongs the life of S&C, therefore reducing maintenance, reduces whole life cost. We talked about the boots off the ballast, which is a positive. We think it meets Network Rail's challenge statement, or we've tried to help meet Network Rail's challenge statements. And as we just said, there are a lot of kind of things we can look at and developments and try and understand. And you can move across into catenaries and signalling areas where just a matter of understanding what people's problems are, trying to work to help with the solution. Yeah, I think
three of those come into that category I spoke about earlier, about prolonging life of S&C, reduces maintenance and reduces whole life costs. It's all to do with the way that it's installed into track. That has a big impact.
Yeah. I think that's it. Thank you very much for your time. Appreciate it.
Okay, thank you very much, Neil and Steve. Are there any questions in the room or online?
I think there was one. Well, sorry, I think there was one online. Yours? Just a second.
Yeah, I've got one question, I think it's from Catriona. Why don't Hypertraxs the Oslo or Progress or license them to do so? It's not transporting to another location track work. Is it a concern over quality? And what is the estimated effective asset life of the coating? So I think there was two questions in there, sorry.
Yeah, well, as we said on the slides, taking a broader brush, the initial kind of view was you're adding 40% to asset life. That's a kind of a mean average, really. We think it's a bit higher than that, really, but especially in Nottingham, you know, we missed 3 interventions on that. The Oslo, the Progress, the BAE, it would mean setting up, it's not saying it couldn't be done, but it would need setting up a plant at each of these. Throughout the trials, we actually put in track Progress switches, Oslo switches, BAE switches, trackwork switches. So as we said earlier, you've got to have a methodology of being able to coat them. We Network Rail, as we know, moved lots and lots of items about. They've got a pre-issue process, so a manganese crossing from Scotland will end up at Sandy because that's where it needs to go in. So that kind of process exists already, that things get moved about. So really, it's just starting off sensibly with a coating plant where components would be coated, like crossings, as Neil said, get sent somewhere because they need explosive hardening, and they get returned to where they need to be to make the components. So that's the model that we need to start with.
I think life extension depends a lot on geometry. You know, you've got areas where I've done a lot of work with Crossrail, and they've got an area of plain line that the TME knew they'd have to change the rails every 9 months because they was digging the tunnels. Basically, they couldn't go through a building or a structure, or if they got the underground, so basically they had to put a curve in it and put a cant on it. But they were quite aware that they have to change that every 8 months because the sideway. So, you know, to me, that would be a perfect opportunity to trial it at that point there, you know, when they're putting it in next. So, you know, and so dependent on geometry, it's like I said, when we're coming into stations, you've got big curves coming in, you've got ladders coming through it. Well, the trains are coming slower, puts more friction on, put more force and friction into it. So, you know, life expectancy can only be taken from the expectancy of the life of your switch you've got for that geometry.
Yeah, there's another question online from Emma. Are you in contact with anyone from Wales and Western region or given a presentation there? And I don't know if Martin's got anything to add. As Western Wales,
Nothing personal.
no, sorry.
Very interesting presentation, although, but I got that, I'm afraid.
No, sorry. Yeah, I don't know if you got a presentation present in Western Wales.
Well, I've spoken a lot to Dan Collins over the years, basically, and we have offered. I mean, Dan, I think it was Dan that facilitated or helped facilitate this slot, and we've offered to kind of go and present to any interested party, and we would be more than happy to go. But we've not actually spoken to anybody, but Dan did mention that it might be an opportunity in the future. Mm-hmm. It's really. I think to be honest about this, when we started this process, and Neil was still involved, and there was a lot of interest, and everybody said, yeah, this is we should pursue this. We started, as I mentioned, doing some roadshows, and we were going out to various kind of depots and meeting the guys from the route, and we got an awful lot of excitement and interest, and saying, oh, this is, you know, we should be trying this. But I think we were actually. We were ramping up enthusiasm for a product which they couldn't order. So we started over years, saying, look guys, you need to back off, because at the end of every session they were saying, right, where do we get this from? And I was having to say, you can't actually order it in a minute. So, you know, right, oh, great. So we didn't, you know, we did stop a little bit of doing that. But as I say, it appears, hopefully, that we seem to have a way through now to be able to just provide the solution to Network Rail, which we're happy to work now with Network Rail. And if we got an opportunity to present to anybody else, we would be more than happy to do that.
I think what it was is, no disrespect, but it's to the level where you pitched it. If you tell somebody in the maintenance DU that you've got something that'll extend the lifetime of his S&C. And basically, he was going to want that. He's going to jump on that straight away. But it's the hoops at higher levels that you have to go through to be able to get access to that for the guys on maintenance. So hopefully now with Steve's news, then these guys can start getting a little bit more excited again, because there's a possibility they will get access to it at some point.
Thank you. Sorry, I think Catriona, I might have misunderstood her question. So if you want to come off mute, Catriona, and ask your question.
Yes, it was about the asset life. And it's like, for how many years is the coating going to be effective? So is it like X number of years that you've already had it on site in trials? Or have you put it in a lab to anticipate that actually it'll stay on there for X number of passage of trains?
I think for me on that one is that you can't guarantee of the wheel profiles that's going to be running through it. It's dependent on the geometry of the S&C and the location. It's on the load of traffic that's going through it and the type of traffic that's going through it. So, trying to put on a time on it would be quite difficult individually. You couldn't say everybody's going to get 2 years extra life out of it, because it's dependent on location.
And I think some would get 3 years extra life and some might get 15 months extra life, but it's all on the positive side. So, and that's why we gave.
No, I got that. Maybe I'm not being clear. At what stage will the coating start to kind of wear off?
The coating starts to wear probably fairly quickly, or starts to morph into a different pattern, and you kind of get scarring. But it actually morphs into the subsurface and continues to do its job. So it doesn't sit there like a Teflon pan, and it completely looks the same after 16 weeks. It does have a kind of a lifespan, and it starts to kind of degrade. But while it's doing that, and while it's going through the beginning of its life to the end of its life, and it'll obviously look very different at the end, it's kind of done its job by that point, because somebody would say
Sacrificial coating.
it's a sacrificial coating, and somebody would say, well, I would have weld repaired that at 16 weeks, but he's standing there at 31 weeks saying that. So that's really what it's about. And as Neil said, it's very different depending on where the geometry, but generally it's very positive.
It's a little bit like EDH. Before we had EDH for cast manganese crossings, you had a 12-week hardening period where you got the soft materials and it pushed it through and head hardened over 12 weeks. That's when you went in and you dress your crossing noses. EDH has taken that away. So basically, I think the coating, what it does is it takes that initial, it starts off as a grey colour, but Andy tells me that it looks like stainless steel after a few weeks, because it takes that top off and it hardens. The more that goes through it, the more it hardens.
So you would expect that 40% to still be just as good in the years beyond the trials years. Is that what you're saying? Or does it become less effective? So if like the increase in the asset rail life is say 40% for the first year or two, will it still be will that number start to reduce? And will people say, if they were previously booking in, weld repairs, will they have to start doing those, but maybe at a lower frequency?
Yeah, basically, yeah, you've just bought life extension with it, really. So that's what the business case was. That eventually it will wear. It's not, it's not a kind of a magic solution. But what it's basically done is bought you a life extension before you've got to do first maintenance.
I think it's a little bit like a tyre. You've got an indicator that tells you when it's at its wear level. So if you've got some sort of log that tells you, you can see that you're coming down to the level where now you need to monitor it.
It's almost where the coating...
Would it go back to your uncoated frequency of interventions then? Or does it get slightly less?
Yeah, once the coating's gone, and as you pointed out, sacrificial, once that's done its life extension job, and actually you look at it and say there's very little coating left on, in effect it becomes just a normal switch at that point, but you've had the benefit.
Okay, so it might only be a year before you get, you might only reap the benefit for a year or so, is it?
dependent on location. Like I said, it's dependent on switch size, dependent on location. The bigger the switch size, the less wear factor you're going to get.
And to date, what period have you experienced?
Well, over the trials, we've had various kind of levels of success, and some have lasted, 20% longer, some have lasted 60% longer. So I think that the whole point is that you're trying to just extend the life of the component in track. When the coating's done its job, then you've had the benefit. It will just become a normal standard coating.
Okay, so that's it. It becomes a normal. Okay. Thank you.
Yeah. Okay. Thank you.
Thanks.
We've got no more questions online that I can see. Is there anyone?
Any questions in the room?
I don't know. The only thought is if you're coming from a design side of it and you've got the maintenance side of it, it needs to go up the food chain to those above. I'm teaching you to suck eggs here. But, the people at the top that are in the middle that look over the whole thing need to be able to go, this product is available. We can specify it through the design side of it, and we can specify it through the maintenance side of it. And as that filters down, then more people can use it.
That's always been an issue for me when I was working for Network Rail, is I used to develop a lot of things, components and tools. And basically what you have to do is you have to go through the approval stages, but nobody tells anybody that it's there. That's one of the issues that we've got. Nobody says, alert, there is now this product that you can get. What you do is you get your certificate, that's it. Then it's up to you then to sell your product.
It's all done by rumour.
Yes.
I mean, we're designers.
Well,
It's the same in overhead lines.
We occasionally get updates.
Oh, we hear this thing might exist.
I think
and you've got to go try and find the product approval certificate somewhere.
Most of the time they only brief out standard changes. You know what I mean? They're telling you that there's a product that's going to improve. I mean, I developed lots of stuff over the 17 years I worked for Network Rail. I do presentations now for the PWI. I was up in Scotland the other week, working with Brian Counter, and we was doing the Wakes delivery team up in Scotland, doing on the S&C refurbishment programme. And basically, I was showing them some stuff that I introduced 17, 18 years ago. No, 20 odd years ago. And basically, they didn't even know it existed. And I says, have you got the pad number? I says, there's your pad number. Do you understand me? I was doing presentations on behalf of the National Reliabilities team, all the way through the routes. We all took a route each individual reliability specialist, and basically briefed it all out. But the problem of it is with the business keeps changing, keep changing.
Network Rail's got no corporate.
You can tell them 1 week, but then they'll be gone the next. So everything that you've told them that week all disappears. This is why it needs to be embedded into the business, so people have got vision. And that's one of the biggest issues.
But just to be clear on your point, it hasn't been available.
Yeah.
Well, so it's not that. Well, why hasn't we heard about it? It hasn't been available whilst we've been trying to get through the trials and get through the, the process, which we're hoping that we now found a way through. So we will. Yeah, it's our intention, as we did early on and stopped, as I explained. It's our intention to work with Network Rail and visit the key people within the routes and Wales and Western and whoever wants and answer the questions and give them more information. Once we're able to know that we can actually offer the product to people, so I think we're hopefully very close to doing that.
I think the main reason what focus was lost within Network Rail was that we was trying to overcome an issue that was engineered in through design of a new S&C rail profile. Now the theory was it would be great, and the theory was that the componentry would last a lifetime of the S&C. That was theoretical. Actually it doesn't, and I've been briefing this out for years, but there is no frequencies set, because everybody says it will last forever, basically. There is no maintenance frequencies to intervene on components, and this is the issue you have when maintenance are going out there to failures and don't really know the underlying cause, what's causing it. That's my job, that's what I do. I find the underlying cause and then overcome it, then you get points performance.
I think we can draw this meeting to a close. So Simon, I invite you to the.
Yeah. No, if we could all show Neil and Steve our normal thanks then our normal method, that would be much appreciated. Thank you for coming.
Yeah, thanks for the opportunity. I really appreciate it, and hope you've found it interesting.
Yeah, and Emma online wants me to pass on her email address to you.
Okay.
So you've got another presentation to do, it sounds.
Yeah, sure. No problem.
Thank you very much.
Okay,
Lovely, thank you.
Thank you very much, everybody.
Thank you.
We'll see you on